Okay, so good morning everyone again, and thank you for connecting to ACER's webinar on the amendments to the electricity grid connection network code. This time around, the consultation is on the draft amendments to the HVDC network code. My name is Urs Gabriel, and I'll be chairing this webinar. And today with me are my colleagues, Christian Winkler, who will present the process for submitting responses to the public consultation and timeline for the amendments to the network code HVDC. Then Yorgos Antonopoulos, who will present ACER's draft amendments, and Lila Vasilaki, who will lead the Q&A session. Can I have the next slide and the housekeeping rules? Thank you. The housekeeping rules, next one. So we decided to have the following housekeeping rules. So your microphones are muted by default on our side. We don't have the chat in order to streamline all the questions and answers via the raising your hand function. So you will be invited to raise your hand after the presentations, and you will be given the floor and unmuted. We will unmute your mic. All the slides from this webinar will be uploaded to the ACER website after the webinar, and we will have two basically Q&A sessions, one after a Christian presentation on the process for submitting the responses to public consultation. So those would be the process related or consultation related questions addressed to him, and then the substance related questions will be under the Q&A led by Lila Vasilaki after Yorgos' presentation of the amendments, ACER proposed amendments to the HVDC network code. With this being said, I invite Christian to present the process for submitting stakeholders' responses. Thank you.
Good morning, everyone. As Uros said, I'll be presenting the actual process for your contributions, how to add your contributions to the current NC HVDC. Now, the actual process only consists of 3 quite easy steps. In the first steps, you will download the Word file containing our amendments for the NC HVDC proposal, in which, for step 2, you will go through the actual survey or consultation form, where you will add your comments or additional text. And in step 3, you will then upload the Word file from step 1, in which you will also add your text proposals and so on. Please note that when uploading the actual Word file, you use the track changes function. Now for step 2, where you will be adding your text to the survey tool, please note that the actual structure follows that of the NC HVDC, with all of the deleted and new articles also in. So you can add comments to all existing and all former, all current and former articles. Now the actual structure is of 4 parts. In the first column, you will add your only comments. In the second column, if you have a proposal for new text, that will go in column 2. In column 3, you can add whole new articles if you feel the need to do so. And if you feel that your comments require additional justification, such as tables or graphs, please add them in part 4. Now, in the final part, you will upload the Word file downloaded in step 1, where you will rename it ACER draft HVDC and then your name, so that we know from who it came from. Please again know that you have to turn on track changes mode. And considering that there are certain character limitations in the actual survey tool, try to make the text proposals in the Word file and in the survey tool as consistent as possible. But again, there is a character limit of 5,000 words. You can also add additional context to your argument with graphs and tables and so on. With that, I think that's all on the procedural side. So if there are any questions, please, now is the time. I don't see any hands. So with that, I'm giving it over to Yorgos.
Thanks, Christian. Let me take control of the slides. Just a couple of also points to complement. Of course, stakeholders can actually ask any questions at the Q&A as well, also for this process-wise approach. A couple of points, stakeholders who have already taken part in last year's public consultation on the RFG and DC, you will notice that more or less this is the same process as last year or for the other codes. So if you are familiar with the last year's code consultation, then you should be familiar for this one as well. And then you will see in the Word document that you can download from the survey any references to the RFG and DC codes are actually in line with the ACER recommendation to the Commission numbering. So you will have to make sure that you have the RFG and DC proposal from ACER in order to check the references to these codes. So moving on to the timeline, you will see that we are now on the public consultation phase. As you might have already seen, the public consultation has been launched on the 17th of June, and it will run till the 8th of September 2024. And also we have this public webinar that we have today to more or less provide you some input with the process and some main changes to the code. And of course, afterwards, we intend, following the end of the public consultation, to evaluate the responses from stakeholders, and then it will be the recommendation drafting along with the internal process that we have within ACER, and then of course the finalization of the amendments, and then we anticipate at the end of the year to go through our internal Board of Regulators approval process, and then of course at the end to submit it to the European Commission the same way as we did last year for the RFG and DC. So you will see here, as I said before, we have this 12 weeks long public consultation. The survey has been launched on the 17th of June. And of course, we all invite stakeholders to comment on this proposal based on what Christian said regarding the process. And we have the Grid Connection European Stakeholder Committee expert group on connection requirements for offshore systems proposal that forms the basis for our ACER draft amendment proposal. And we also invite stakeholders to download this public report from the expert group and to have a look as well. And of course, we have this webinar, as I mentioned before, for the key proposals and the process. So now moving on to the main proposed amendments to the Grid Connection Network Code, which is the Network Code HVDC. So starting off with the motivation of the proposed amendments, as with the other codes, we are safeguarding the future system needs in the European Union while ensuring that the rules are all defined and harmonized to the necessary degree, taking into account, of course, proportionality and subsidiarity principles. And also, there is the substantial growth expected in the future in generation capacity of isolated offshore AC networks, which they are called AC hubs. Because currently most of the offshore HVDC systems are connected radially to the mainland, whereas in the future we are expecting sort of a hybrid situation where you might have interconnectors between member states and synchronous areas going through these AC hubs with substantial generation in there. And also we are anticipating also some storage and demand to be connected in those hubs, which is not the case at the moment. We also will have a high penetration of these HVDC systems as well as converter-based power park modules, which will create some new system needs. And of course, with these needs will have to be catered for by appropriate system users' capabilities. And of course, another motivation is to maintain system security, reliability, cost-effective system design, and system operation, also in that future meshed offshore HVDC systems. And finally, based on our ACER recommendation on the amendment proposals for the requirements for generators and demand connection codes, we are ensuring consistency with our recommendation to these two network codes as we've done last year. So moving on to the scope, just to give you a graphic in the representation of what is the current scope of the network code HVDC. So we'll see here that we have HVDC systems in scope of the current HVDC code of connecting synchronous areas of or control areas, including back-to-back schemes. We also covering embedded HVDC systems within one control area. And also you will notice we have connection points defined and interface points defined. And of course, we have this radial connected power park module, which are connected through the interface point and through an HVDC system to the main grid. So that's what the current HVDC code scope is. So moving on to the proposed HVDC scope, again, this graphic representation is taken from the report from the expert group on connection requirements for offshore systems. And you will see, first of all, that we have three new components or modules or units that are included in the scope. So we have asynchronously connected electricity storage modules. We have asynchronously connected demand facilities. And we also have asynchronously connected power to gas demand units. So you'll see these are effectively connected in isolated AC systems. And also the other component that we have included in the scope, based also on the expert group's proposal, is to have HVDC system connecting isolated AC networks. So because in the future, you might have as I mentioned before, AC hubs or AC buses that are connected with other AC buses offshore with HVDC systems. So that's also captured in the proposed amendments with the HVDC code. And you will see that we have the remote and HVDC converter station marked as blue in this graphical representation. And we also retain the connection points and interface points as the current code dictates. So we have requirements applying at the connection point and also requirements applying at the interface point. So moving on to the actual amendment proposal. So you might already have seen, if you have downloaded the legal text, we'll have the introduction of new system users, and of course we have new legal definitions. We have the asynchronously connected power to gas demand unit, which is the power to gas demand unit that's connected via an interface point to one or more remote and HVDC converter stations. That's in line with the graphical representation that I showed before. And we also have the asynchronously connected electricity storage module, which again, it's an electricity storage module that's connected via an interface point to one or more remote and HVDC converter stations, and the same approach for the asynchronously connected demand facility. And we also have changed the naming of the DC connected power park module, which is the current definition in the current RFG network code HVDC. and which becomes now a synchronously connected power park module. And the legal definition for that, as you can see here, it's a power park module that's connected via an interface point to one or more remote end HVDC converter stations. Another change that we have introduced, this is actually an improvement based on our internal processes with regulators. And this is to slightly change the definition of an isolated AC network, which according to the expert group means an AC network which is not part of a synchronous area, which is connected to a synchronous area via one or more HVDC systems. And the reason for the change is that this definition could be misunderstood to include islands of member states which are not in scope of current network code HVDC. And if you see the current, the existing Article 3, paragraph 7b, which actually says that the regulation does not apply to HVDC systems or DC connected power park modules, but are connected to transmission system and distribution systems of islands of member states, which are not operated synchronously with continental Europe, Great Britain, Nordic Ireland, and Northern Ireland or Baltics. So effectively what we have done here, which is introduced the text in red that you will see here, which effectively complements the text in Article 3.7b. So now the definition of an isolated AC network includes this part, which is this definition does not include the transmission distribution systems or parts of islands of member states of which the systems are not operated synchronously with either the continental Europe, Nordic Ireland, and Northern Ireland or Baltic synchronous area. Moving on with other draft proposals regarding the significant modernization. Again, the proposal is based on the final report by the expert group. However, to aid the harmonization of the criteria that define a significant modernization, we are also proposing to introduce a fixed percentage for each of the criteria, above which the asynchronous power park modules, the asynchronous demand facilities, asynchronous power to gas demand units, or asynchronous electricity storage modules is considered significantly modernized. So we are inviting stakeholders to propose a suitable value or provide us any comments regarding this amendment proposal. And also we have the rate of change of frequency withstand capability of HVDC systems. Again, the proposal is based on the final report by the expert group, and the rate of change of frequency requirements for HVDC systems are following the requirements in the ACER recommendation for the requirements for generators that we have recommended the end of last year. And also in line with the requirement for generators amendment proposal, we have a grid forming capability introduced in this code. Again, the proposal is based on the final report by the expert group, and we have inclusion of the grid forming technical requirements for HVDC systems, and also asynchronous connected power park modules and electricity storage modules. And we also are providing, again, in line with the expert group proposal, technical requirements as well as the control chain, starting from the connection point of the HVDC station down to the remote end station and the generation and storage connected to the remote and HVDC station. And this is because there needs to be a chain of events in case there is a disturbance or there is a need of the grid forming capability in order to move down from the HVDC system up to the generation and storage, and then these devices in order to be able to complement and provide the support it needed to the system. Regarding the technical requirements for system users, of course, we have technical requirements for these additional system users, which mainly follow requirements from ACER recommendation on the requirements for generators and demand connection amendment proposal, unless, of course, there are specific requirements are provided in the proposed amendments for the network code HVDC. So you will see that they are mainly referring to the ACER recommendation on these previous two codes. However, if there are any changes, of course, there are specific requirements included in the HVDC code. Regarding the forced oscillations, again, in line with requirements for generators amendment proposal, we have included the requirements for asynchronously connected power park modules for forced oscillations from the ACER recommendation on the NC RFG. And of course, we have referenced the relevant article for offshore power park modules included in the NC HVDC. We also have a limited frequency sensitive mode under frequency consumption, which is for the asynchronously connected power to gas demand units. And again, this is proposal based on the final report by the expert group. And then finally, we have the fault write-through capability, which it's a fault write-through capability for an asynchronously connected power to gas demand unit. Again, proposal is based on the final report by the expert group. And we have introduced some additional amendments regarding the simulation models, which is talking about the simulation models that properly reflect the behavior of the HVDC system. And this proposal is based on the final report by the expert group on interaction studies and simulation models for power generating modules and HVDC expert group. And finally, we have some changes to the voltage ranges for these devices that are in scope of the code. And you might remember, or you might have seen that the current code does not separate the voltage ranges based on the rated voltage. It's just there is some ranges for in per unit that are applying to all the voltage, the rated voltages, whereas in this case, in line with the RFG recommendation as well, the voltage ranges have been separated and is amended to reflect the rated voltage. And again, the proposal is based on the final report by the expert group. So this is the final slide regarding the main draft amendment proposals. And then we can go to the Q&A session.
Morning. This is the Q&A session. Please proceed with any questions you have on the amendments of the HVDC. Don't see any questions.
If you have any questions, please raise your hand. We should be able to see a raised hand and then address you. Now they're coming. Good. Thank you.
Yes, Diebold, please proceed with your question.
Yorgos will unmute you and then you can speak.
Yeah, give us, yeah.
Sorry. I already have.
I think it's possible to speak now, yeah.
No. Yes, hello, can you hear me now? Great, thank you.
Yes.
Thank you very much for the presentation. I was wondering if you have different appliances connected behind the same HVDC line, but not going back to AC. Like if you have several DC connected appliances, is it covered by this code or not? Like if you have like a battery and a power to gas, both connected at the same DC point, and then you have one AC/DC inverter to the grid.
Yes, it's covered the same way that it's covered if they are connected individually through different converters to the HVDC system. So what we're talking about here, if you see, let me go back to the slide with a graphical representation. So you will see here, for example, you might have a electricity storage module which is separate from the power park module, or you could have storage connected through a DC to the power park module, so that we have a single converter connecting the combined system to the interface point. So that's also covered as well.
Okay, thank you.
Thank you.
We proceed with Thierry.
Yes, thanks for the presentation and all the explanations. I have one question regarding all the interactions, likely interactions between HVDC interconnections and generators, so mainly big power plants. For instance, hyposynchronous torsional oscillations, which may endanger the big power plants. Is this covered specifically in the simulation topics you mentioned, Georgios, or where will it be focused on? This specific point?
There is interaction studies articles you might know in the current HVDC code, which is included in there. Of course, the code dictates certain studies. Also, the simulation models take into account these interaction studies as well. But at the same time, it is possible for the TSOs to request additional studies based on the local issues that they have identified in their system. So it's the network code includes the sort of the general need for harmonization, but of course, if there are any local specificities, of course, they will be taken into account locally as well.
Okay, thank you. Thanks for the answer.
Thank you.
Thank you, Thierry. We now go on to Anthony's question. Please proceed.
Oh, good. Yeah, good morning. Thank you very much. Very interesting presentation. It's much appreciated. Got three questions. I guess we're in a difficult position because obviously GB unfortunately is no longer part of Europe, which is a great shame. But obviously, because you've got interconnection between different countries, and obviously that creates some interesting points. I've got 3 points. The first is I noticed you use the term interface point. It might be better if we use a term like HVDC interface point, because we already use interface point. I know that we won't be bound by the requirement, but for clarification, it might be easier if we just had the term HVDC interface point as per the current HVDC 1 code, because we already use a term interface point, and that could cause confusion using the same term for different, which has different meanings. That's a minor point. I can put that in the consultation. The other point I've got, we haven't really captured this, but I did take the opportunity to look at the consultation. With regard to grid forming, my understanding is that it's not mandatory unless it's the requirements defined by the TSO for the provision of grid forming. That's my understanding. The one question I have got, though, is and this is probably again something I probably need to put in the consultation, but my understanding is that there's a clause in there relating to the provision of storage and the contribution to inertia. And if you had something, quite a small country connected to quite a small synchronous area connected to quite a large synchronous area, say Ireland and continental Europe, my understanding is there's a clause in there that says if grid forming is specified, then the energy should be taken from an external source, which I understand could be taken from the other synchronous area. So the other synchronous area is seen as an infinite battery. That could have quite substantive implications for the remote synchronous area. I just want to make sure my understanding is correct. It might be better for the actual storage to be provided by a third party or as a storage element within the HVDC link. And I'm just wondering if you have any views on that. Just before we open it up and see questions, a bit like saying if you had, say, Ireland and the continental Europe and an interconnector which was like 2,000 megawatts, and the amount of grid forming required for storage purposes in terms of the energy, the static inertia requirement was 700 megawatts. That could have very significant implications for the smaller synchronous area. I just wondered if you have any views on that. Thank you.
Thank you for the questions. Just to understand, so you're regarding your first question, you're referring to the effects essentially to use the same definition that is currently existing in the HVDC code, which is the HVDC interface point, instead of just saying interface point on its own. Okay,
yeah,
thank you.
That's it. Yeah.
Okay.
We did make that. Yeah, sorry, we did make that comment when HVDC 1 progressed. When we were member state and it was accepted, it should be HVDC interface point. So it's just a point. We'll put it in the response, but it's just a point worth noting to save any confusion. Thank you very much.
Okay, thank you. Regarding your second question, the grid forming requirements, as you said, they are not mandatory from the HVDC system point of view. But you will see that now we have the recommendation for the RFG, including grid forming capabilities in the power park modules. So essentially what this means is that we are using the power park modules capabilities that are connected to the interface point, and through a control chain, which is included in the legal text, we are using these capabilities and the HVDC's capabilities in order to support the main grid. So it's not providing support the other way around. It's more like the HVDC hub connected at the remoted station is providing support to the mainland through the HVDC system. And that's hence the reason for the need to provide control chain between the HVDC system and the connected equipment at the other end.
Yeah, that's helpful. I understand the intention. I just wanted to make sure there's no unintended consequence of utilising the remote end as effectively an infinite battery that could have stability implications on the remote end. But that's helpful. Thank you very much.
Yeah, thank you.
Thank you, Anthony. And we have Sahab for the next question, please.
Yes, hello. I also have a question regarding the grid forming requirements. So as far as I remember from the previous webinars, there was no specific criteria here defined, and it was all, let's say, given the option to be proposed by the TSOs or at the national level. Is this still the case, or can you elaborate a bit, like say, what is the grid forming requirements if one tries to provide one?
Yes, thank you for your question. Indeed, this is the case as well in this time around. Of course, when we are referring to the grid forming for the power park modules and the electricity storage modules, of course, the requirements that are proposed in the RFG apply. So you have already seen the requirement for generators amendment proposal. So that's, as you mentioned before, that they don't have specific requirements in there, so they will be defined at the national level. And that's the same essentially for the HVDC systems as well. So it's there are certain requirements and capabilities, but in detail, the detailed requirements will be defined at the national level.
Okay, thank you.
Thank you, Sahab. I see no further questions in the chat. If this is the case, we'll give the floor to Uros.
Thank you, Lila. I also don't see any further raised hands. That would be still an opportunity for you to do so in case you have either a process-wise question, the consultation question, or the substance question on the presentation that was given by Yorgos. Okay.
We do have a hand.
Yeah.
Yes,
Roberto.
Roberto, please. You can proceed with your question. Thank you.
Yes. Maybe the question regarding the interface and the connection point, when you say that you might have PPMs connected to the interface point, but you were saying also that you would like a combined kind of behavior, including the behavior, the PPM and the behavior of the HVDC system. So are the requirements at the interface point, are the requirements at the connection points, or are at both? And what is the expected combined behavior there? So who is taking care of the coordination, so to say? This is the main question.
Thank you for the question. So the requirements at the connected equipment, so we're talking about the PPMs, the power to gas and the electricity storage modules, so requirements are at the interface point. Whereas the HVDC system, we have two essentially different requirements, capabilities. We have the converter station, which is connected with the mainland, which is the connection point. and we also have the remote end HVDC system converter station. And also this is the case in the current HVDC code. So we have different requirements for the connection point and different requirements for the remote end HVDC system, which is at the interface point. And of course, the interaction, there should be a coordination, because of course the converter station on the mainland is the one which senses the differences in frequency on the mainland. And of course, there needs to be a control chain reaction in order this to be communicated to the system, to the equipment like the power pack modules and the electricity storage modules at the remote and connected interface point. So that's there is an additional, effectively, legal text based on the proposal by the expert group to take into account this communication between the equipment connected.
And if I may ask also kind of a follow-up question, is this communication kind of intended by means of wired communication, or it is more on the level of, I don't know, electrical quantities, like whatever frequency voltages?
I don't remember now if this is specifically mentioned. Let me see if I can find the relevant part in the legal text. So this is actually Article 40B in the proposed legal text. Yeah, so it's not specifically mentioned. It's just it needs to have the capability to provide synthetic inertia within the power pack module's capabilities, if required by the relevant system operator. So it's essentially it's not specifically mentioned how this communication will be done.
Okay.
But Mario, maybe Mario can have some more additional points or comments on that as well.
Yeah, so good morning, everyone. This is just on behalf of the expert group CROSS, because as mentioned before, this consultation was done based on a report, a consolidated report of the stakeholder during the first period. So I want just to add two clarifications that we had in the expert group report and its use, and of course this will be consulted. First, for the interface point, the current version of the HVDC 1.0, it has indeed the notion of HVDC interface point, but it was also, let's say, designed or drafted more than 10 years ago, knowing that we have only one PPM connected to a remote end station. So there is only one point, and it was called HVDC interface point. In the future, as was mentioned and as we have discussed also in the expert group, we will see the isolated AC systems to be bigger, and there will be also impedances between the HVDC remote end station and the 1, 2, or more grid users offshore. That's why we said, okay, instead of having the HVDC, we use only the notion of interface point, and because we cannot use the notion of connection point, it is to a synchronous area as it's drafted in RFG. So that was the only motivation why we removed the term HVDC, because we are not connecting only an HVDC with a PPM. It could be also a bigger isolated system. There will be more requirements, etc. That's one point. The second comment I had was there was a comment from Thibault. I think in the HVDC, in the network of the HVDC, all the requirements are the connection point, AC connection point. It's by default all the three and connection codes, RFG, DCC, and HVDC. They imply requirements at the AC side in principle. So there is no requirements in the HVDC. Or let's say NC HVDC 2.0 applied to any DC, let's say, terminal. And the third one, what was the case with the control chain, is that in order for the remote end station, and the remote end station is not a station which is connected to a small synchronous area. So if you have islet, for example, you don't have a remote end station. It's only for, let's say, HVDC stations which are connected to hubs in principle, and which and the remote end station could create the control chain reaction in order to support the onshore station. So if the onshore station has the grid forming capability, the relevant TSO has the right to request the remote end station to trigger a control chain reaction by modifying, let's say, frequency of the isolated system, which is isolated system. The frequency is defined in principle by the remote end. So these just 3 comments, as I said, in support of the discussion, because it was part also of the expert group report. Yeah, thanks.
Thanks, Mario, for the clarifications and the explanations.
Anthony, please.
Can you hear me? Hopefully, suddenly
we can hear you now. Yes.
Good. Okay. Sorry, I had a blip on the screen here. I just say thank you to Mario. Just one comment about the HVDC interface point. I understand that it doesn't have to be HVDC interface point. It could be another term as long as it's not just interface point. So you can use whatever term you like, but as long as it's not interface point, that would really help us out. But I'll put that in the comments as a suggestion. Thank you very much.
Yeah, the only problem we have is that the connection point is a red one. It's in a synchronous area and it's understood as such, and we cannot use again the connection point for connection of grid users on isolated systems offshore, for example. That's why it came up, the idea of isolated, of interface point, and of course this is open to consultation now. Just in terms of the expert group, how the expert group ended to this.
Yeah, no, that's fine. I think we can easily sort this out. It's just making sure we don't get confused with one particular term. But I'll put that in. That's very helpful anyway. I mean, connection point I'm not so concerned about. It's more the interface point I've got a bit of an issue with. But we can easily sort that out. And thank you for taking the time to explain it. Thank you.
I don't see any other questions.
Okay. If there are no additional questions to us, then I would like to thank you all for joining, but also for actively participating by posing your questions. As mentioned earlier, the consultation is open till 8th of September, and we are inviting you all to submit your comments via the consultation tool explained by Christian before. But anyhow, we remain also available to address any follow-up questions in a bilateral form. You can reach out to us using the functional mailbox address published on the dedicated consultation page on our website. With this, I thank you all again for joining and wish you a nice day. Thank you. Bye-bye.
Thank you. Bye.